Everybody, welcome to your very first flipped AP statistics lesson. This is video 1 and it's going to be about graphical displays of data. So before we begin, what is data? Data is just factual information that we use as a basis for reasoning, discussion, calculation. Basically, AP statistics is all about using data. And data falls into two types. Our data can be quantitative or it can be categorical, also known as qualitative. Quantitative variables or quantitative data use numerical values like gathering information on people's heights or people's SAT scores or how much money people have in their wallet. Whereas categorical data or qualitative data places an individual into one of several groups or categories. For example, I might gather information on how many people of each gender there are in a particular class, or information about race, or information about people's favorite TV show. In this video, you're going to learn how to make 4 different kinds of graphical displays for data. We're going to learn about bar graphs, dot plots, stem plots, and histograms. And then there are 2 more that you're going to be responsible for, box plots and ogives, but we're going to learn about those later. First type of graph we're going to learn about is the dot plot. Dot plots are just used for quantitative data, so just when we're dealing with numerical values, and it's used for univariate data, which means data where we only have one variable. And this is what a dot plot looks like down here. We have the numerical values on the bottom, and then the number of dots above a certain value corresponds to how many individuals take on that value. So let's do an example. We're going to make a dot plot of this set of data. This represents a set of AP scores. So I have our horizontal axis down here, and I'm going to start by labeling it. This represents AP scores, so I'm going to write scores. And my values range from 1 to 5, so I'm going to label those. That represents 1, that represents 2, 3, 4, and 5. And then I'm going to place the number of dots above each number corresponding to how many times that score occurred. So looking at 1, I see it happened once, twice, that's it. So I'm going to place 2 dots equal spaced above the 1. Next I move on to 2s and I see 1, 2, 3, 3 2s. So I try to make it as even as possible and make 1, 2, 3 dots above the 2. Now we move on to 3s and I see 1, 2, 3, 4, 5, 6, 7, 8, 9 3s. So now I have to make 9 dots. And on to 4s, I see 1, 2, 3, 4 4s. 1, 2, 3, 4. Those aren't very equally spaced, but I'm doing the best I can. And I see 2 students got a 5, 1, 2, and there's my dot plot. And there are certain things I can tell from this. For example, I can very clearly see that 3 was the most frequent score. I can see that this is a pretty symmetric distribution. There's approximately the same number of 2s as 4s and approximately the same number of 1s as 5s. And that's about it for dot plots. The next graph I'm just going to talk about briefly. That's a bar graph. We use this for categorical data. So this is the first display of categorical data that we're going to talk about. The horizontal axis contains the values of the variable. In this case, we took a poll and found out what students' favorite juice flavors or colors were, and they like red, orange, yellow, and purple, and so we label the x-axis with those different values. The vertical axis is the frequency. How many students liked red? How many students liked orange? We can see that 10 students prefer to drink yellow juice. So one thing to point out is that the order along the x-axis doesn't matter. Whereas with a dot plot, we put them in numerical order, 1, 2, 3, 4, 5. Colors don't have an order. So red, orange, yellow, purple, I could exchange any of those without a problem. The next type of graph I'm going to talk about is similar to a bar graph. It's called a histogram. And the main difference is that we use histograms with quantitative data, whereas we use bar graphs with categorical data. The other big difference is that in a histogram, the bars need to be adjacent to each other, meaning they need to be touching, as these are here. And the reason for that is that the x-axis contains numerical data and numbers are continuous. The vertical axis, the y-axis, just like with a bar graph, measures frequency, how many. So this right here is a histogram of the heights of black cherry trees, and on the x-axis we have the heights, and on the y-axis we have the frequency. So I see that there were 3 black cherry trees, that's the 3 right there, with heights between 60 and 65 feet. I can see that there were 8 black cherry trees with heights between 70 and 75 feet. So I'm going to show you how to make a histogram using this set of data. This is quantitative data, and what we have here are a set of IQ scores. So say this is a small class and I gathered what everybody's IQ score is. So I already have my x and y axes drawn in. I'm going to start by labeling them. And the x-axis I'm going to call IQ score. And the y-axis I need to label as frequency. And that's good enough. So what I need to do is look at my data and decide how I want to scale my x-axis. And it looks like I go from 81 up to 145. This is my max, and this is my min. So I think I'd like to go up by tens starting at 80. So I'm just going to have a break in the axis and start at 80 and go up by tens. And notice I have to go all the way up to 150 because my largest value is a little bit over 140. The next step isn't required, but it is helpful to make a frequency table. So what I'm going to do is read off the table and see how many values are between 80 and 90, 90 and 100, 100 and 110, and so on. So I look between 80 and 90, and I think that's just this guy right here. So I have one value between 80 and 90. Between 90 and 100, I actually don't have anybody, so I'm going to write 0. Between 100 and 110, I've got 1, 2, 3, and actually I'm going to wait on this guy. I'm actually going to sort of throw that up into the 110 to 120 category. So I'm going to call this 3, and then remember that I need to include 110 in the 110 to 120 grouping. You can do it either way. Just make sure not to double count that person because they're not special. And number 2, to be consistent. If you're always throwing it in the upper bin, you need to do that each time. So for 110 to 120, that's going to be 1, 2, 3, 4, 5, 6. 120 to 130, that would be 1, 2, 3, 4, 4. 130 to 140 would be 1, 2, 3. The 130 is going to go in the upper bin. 3. And 140 to 150 are these 2. So I'm going to label my y-axis. I'm going to go up by ones. 1, 2, 3, 4, 5, 6, 7. and I'm going to fill in the corresponding bars. So from 80 to 90, my bar needs to have a height of 1. From 90 to 100, I didn't have anybody. That doesn't mean I can skip this. What this means is I have a bar with a height of 0. From 100 to 110, I'm going to have a bar with a height of 3. 110 to 120 has a height of 6. (120 to 130 has a height of 4. 130 to 140 has a height of 3. And we end with a height of 2. Notice my bars all have equal widths. They are touching, except where I have a gap, and that's it. The last graphical display I want to talk about is the stem and leaf plot, which we are now going to call stem plots. Stem plots also used for quantitative data. They give a picture of the shape of a distribution because it's kind of like a sideways histogram, but it actually shows the numerical values. So what this represents, these stems, in this case, represent the tens digit, and these leaves represent the ones digit. So this 2 and this 3 represent 23. So this is a data set that looks like 23, 26, 20, 22, 35, 37, 32, 36, 33. And I actually don't like this example. I like to put my leaves in numerical order, and we'll do an example that looks like that. So in order to create a stem plot, you have to separate each value into a stem and a leaf. The stem is all the values except for the final digit, and the leaves are the final digit. So for this guy, the stem is a 14 and the leaf is a 5. Then you create a vertical column, put the smallest numbers on top and the largest numbers on the bottom, and write each leaf to the right of the stem. It's easier to show you. So we're going to make a stem plot of these same IQ scores, and I know from before that the smallest stem is going to be that 8, and I know that my largest stem is going to be that 14. So I'm going to go 8, 9, 10, 11, 12, 13, 14. And I know that the only leaf associated with a stem of 8 is that 1. I know that in the 90s I don't have anybody. For the 100s I have 101, 106, and 109. So I'm going to write a 1, a 6, and a 9. I know for the 110s I have 110, 112, 113, 10, 12, 13, another 13, and 2 18s. In the 120s, I have a 122, 4, 5, and 6, 2, 4, 5, and 6. In the 130s, I have 130, 34, 34, and 39, 34, 34, and 39. And for the 140s, I have a 142 and a 145. And so this is actually kind of like a histogram, because if you rotate your head 90 degrees to the right, you can sort of see bars corresponding to how many numbers there are. But what's nice about this is that you actually retain the values. You can actually get back to your original data set just by looking at this. Whereas with a histogram, you lose that. I can't look at this and tell you what the raw scores were. So that's all I want to tell you about creating graphical displays. We're going to practice this tomorrow, and please answer the questions at the bottom of the page.